Right? So in this question, what's going to happen is, of course, shadows are not a very good way to measure heights. Right? What if it's a rainy day? What are you going to do? You can't measure the height of the shadow. And so people really needed another way to figure out heights, to figure out distances, really. And the way they eventually did this is they used trigonometry. So just a little spiel about trigonometry. So let's write it down here. So we want to talk about trigonometry. So really, the name tells you exactly what's really going on. So if you look at this, what we have in the name is this word tri, which means 3, and then we have this word gon, which means sided. Right, so 3-sided. I mean, tree like measurement. It's really kind of tree, which you might think of study of measurement or something. So measurement. What trigonometry is, it's really the study of 3-sided figures, the study of triangles. That's all. And what makes it so nice is it's relatively easy to work with. So we have these 3 different actually trigonometric functions. We have what's called the sine function, so it's called sine of theta. We have the cosine of theta, and we have the tan of theta. And they're simply defined. If you have a right triangle, and you call this, they usually call this theta, and they call this the adjacent side, the opposite side, so they use L, and then the hypotenuse. And the sine of theta, theta is some angle like 20 degrees, 30 degrees, some nice angle, is equal to the opposite over the hypotenuse. The cosine of theta is defined to be the adjacent, length of the adjacent side over the hypotenuse. And then the tangent of theta is equal to the opposite over the adjacent. When I was taught this in high school, it was, what does the Indian say? So, ka, toa. So that's how I memorized it. The importance, though, of trigonometry is that it's used in surveying. It's used to figure out basically the distance between 2 points when you can't actually run a tape measure from one point to the other. As an example, suppose you want to figure out the height of a skyscraper. It's not like you can go to the top of the skyscraper and drop down a tape measure and catch it at the bottom. Or you want to figure out the distance you're on between one side of a river and the other side. All right, so you have one person on one side, one on the other. Typically, you can't just throw a tape measure across and have the other person catch it and measure the distance. So this is where trigonometry comes into play. And so we're going to do an example of this. And this problem here, it says, a new guy in town who calls himself a trigonometer runs over to you and snaps your rod. So you're the shadow reckoner, and here comes this trigonometer. And he takes away your rod and snaps it. And he says to you that the days of shadow reckoning are over. He then pulls out a strange-looking device and says that all you need to know is the distance to the obelisk and the angle to the top of the obelisk. He is standing exactly 50 feet away from the obelisk, and the angle is measured at 45 degrees. So first thing I want to do is finish the picture. And so the idea is that here's this guy, the trigonometer, and he's hanging out right here. And it says he's 50 feet from the obelisk. And what this guy has is sort of a sighting device. You can almost make your own. If you remember way back to the school days when you had this sort of protractor. It looks kind of like this. And it had the various degrees here, up to 90 and all the way over to 180. And what you would have on here is a little tube right here. So there'd be a little tube attached right here, and that tube could be moved, at an angle. So you can move this tube, let's say, move it like this. You just turn it right there, and it could turn up. And you would look through that little tube, and what it would tell you is you could sight the peak of that pyramid, and then you could look and figure out what the angle was right here, right, from that. So he's got this little sighting device right here that he's looking through, right, this little tube, right, and he's got a little protractor there that he's looking through, and he can figure out the angle. And so he tells you that this angle here is 45 degrees. And what you want to do now is you want to use a tangent button on your calculator to find the height of the obelisk. And so you say, okay, well, let me label the height here first. So the height, I can use the letter H. And I know that from my trigonometry, the tan of 45 degrees, right, the definition of the tan of theta is the opposite over the adjacent. So it's going to give me H over 50. And I can use my calculator to figure out the tan of 45. Make sure your calculator is in degree mode, so check it, hit mode, and you see down here it says radians or degrees. We want to make sure that we're on degrees, so hit enter on degrees. So now I'm on degree mode, and so I'll take the tan of 45 and hit enter, and I get out 1. So what that means is I can replace this thing with a 1, because tan of 45 was 1. And of course it's equal to H over 50. And I can solve this for H since I'm dividing both sides. To move it over, I multiply. And so this implies that H is actually equal to 50 feet. In part C, they ask, the two heights are slightly different. Can you think of any reason for this? And so the point of this is that there's always going to be some error in our measurements. So there will always be some error in our measurements. The reason for this is obvious. I mean, you have this little sighting device. There's going to be some error in the sighting device. So maybe it's not 45 degrees exactly. Maybe it's a little less. Maybe it's 44 degrees, or maybe it's 46 degrees. And the same thing with the shadow, right? I mean, maybe it's just barely the tip of the shadow, right? Maybe you're off by an inch or something. You're over an inch or less by an inch. There always will be a little bit of error. So but you can kind of guess that the obelisk in this case runs about 50 feet tall.